The evolution of Earth's atmosphere took place in several stages, each marked by significant changes in its composition and the conditions that made life possible. In the earliest phase, known as Phase 1, the Earth's surface was covered with intense volcanic activity. These volcanoes released vast amounts of gases, including carbon dioxide, water vapor, nitrogen, methane, and ammonia into the atmosphere. The atmosphere at this time was dominated by carbon dioxide, with little or no oxygen, resembling the atmospheres of Mars and Venus today. Water vapor released by the volcanoes eventually condensed as the Earth cooled, forming the first oceans. Nitrogen gradually built up in the atmosphere, and small amounts of methane and ammonia were also present, creating a thick, dense atmosphere that was inhospitable to most forms of life as we know it. Phase 2 of the atmospheric evolution began as the Earth continued to cool, leading to the formation of oceans that played a crucial role in absorbing a significant amount of the carbon dioxide from the atmosphere. Much of this carbon dioxide dissolved in the oceans and underwent chemical reactions to form carbonate compounds, which then precipitated out as sediments on the ocean floor, gradually becoming part of rocks such as limestone. At the same time, the first simple life forms began to develop. Around 2.7 billion years ago, algae and other simple photosynthetic organisms started to emerge in the oceans. These organisms absorbed carbon dioxide from the atmosphere for photosynthesis, a process in which they used sunlight to convert carbon dioxide and water into glucose and oxygen. Over millions of years, this photosynthetic activity by algae and green plants significantly reduced the levels of carbon dioxide in the atmosphere, helping to stabilize the climate and provide a basis for more complex forms of life to evolve. Phase 3 saw the continued evolution and proliferation of green plants and algae, which played a vital role in transforming the atmosphere further. As these organisms increased in number, they produced more oxygen as a byproduct of photosynthesis, gradually enriching the atmosphere with oxygen. This accumulation of oxygen in the atmosphere was not immediate but took millions of years, as it first reacted with dissolved iron in the oceans to form iron oxide, which settled to the ocean floor, forming banded iron formations. Once the iron in the oceans was used up, the oxygen began to accumulate in the atmosphere. Over time, the increased oxygen levels allowed for the development of more complex life forms that relied on oxygen for respiration. About 600 million years ago, the oxygen levels became sufficient to support the evolution of multicellular organisms, leading to a dramatic increase in biodiversity. The atmosphere began to resemble its current composition, with about 21% oxygen, which enabled the rise of the diverse life forms that populate the Earth today. The evolution of the atmosphere was a gradual process that transformed a hostile, carbon dioxide-rich environment into one with an oxygen-rich atmosphere, which supports complex life forms. This transformation was driven by natural processes, such as volcanic activity, the formation of oceans, and the photosynthetic activity of early life forms, which fundamentally altered the composition of the atmosphere and set the stage for the development of the diverse ecosystems present on Earth today.